Okay, here we go. 3.5 graphing quadratics. We've learned to factor them. We found them by foiling, and we understand a little bit the math of how we multiply to make them. But we're going to look at the pictures, the graphs that these things make. So we've got, this is a trinomial, right? And we've got these three parameters, A, B, and C. They're like our control knobs that will adjust the shape of this quadratic when we graph it. We're going to start off simply, and we're going to say, suppose B equals 0 and C equals 0, and we're going to just look at y equals ax squared, okay? The A is considered, this is always written from highest degree to lowest degree. That's in what we call standard polynomial form. And then A is the coefficient, it's called, for the x squared term. B is the coefficient for the x term. And C is the constant. It's just a number. There's no x. Don't sub in x for that value. It starts with the letter C, so it's easy to remember. Okay? So if we're looking at y equals then some number times x squared, we're going to just plot some points. The simplest one is if a equals just 1. So we've got y equals x squared. All right? So to plot some points, very simply, we've got our x and y chart. Start off always at 0. That's an easy place. 0 squared is 0. 1, if we sub in 1 for x, and 1 squared will give us 1. If I sub in 2 for x, 2 squared then gives us 4. And we're going to just plot a lot of points. You can get ahead of me if you want. Pause me. 3. If I plug in 3, what do I get? I get 9. And finally, if I plug in 4, I'll get 16. Well, if I go to plot these points on a graph, and there's 1, 2, 3, 4, there's 5, and there's 5, and there's 10. 0, 0, that's the origin. 1, 1, that's right there. 2, 4 is about there. 3, 9 is about there. And then 4, 16 is going to be way up around, maybe about there. If I were to fill in between those, I'd get a curve that looks like that. Okay, well the nice thing about squaring something is that any negative is made positive. So if I had negative 1, 2, 3, and 4, I would get the exact same points, because when I square a negative, it becomes positive. So I get a mirror image going up like this of these points here. And so when we graph this shape, we always get it symmetrical about that vertical line. It's called an axis of symmetry. All right? So the name of this shape is a parabola. That's the quadratic curve. There are many things in nature that follow quadratic curves. Projectiles in motion, if I throw a marker up that traced an upside down parabola, quadratic. So the graphs of these things are really important and important to apply them. So we're going to turn our camera to go over to GeoGebra, which is what I want you to use to finish your worksheet. Okay? So I will try to show you the entire screen. There we go. And so download and get GeoGebra up and running. To do our plotting, it's best if we show the axes and then show a grid. If this is not centered properly, remember you can move it by taking this and then just dragging it around. I think that if we pull this way, we can change the scale or make it bigger. Try to show every point. Oh, it doesn't. There we go. There's 1, 2, 3. And I can do the same this way if I wanted to stretch it that way. All right? I've typed in y equals x squared. You do that down here at the input. You just simply go to your keyboard, y equals x caret to the 2. You hit enter, and up it comes like that. All right? So I can turn this on, and there is my graph of my parabola, just like we've done by plotting points. All right? So in your worksheet, you're going to be typing in different values, y equals 2x, or 4x squared, or y equals 1/2 x squared, and you'll see what that number does to this shape. All right, so that's for you to discover. Good luck.